during his 2 lectures, workshop lectures. That's in physics, to explain the nature of life, mind, consciousness, and matter, and he will soon develop a new physical model of the atom. All of these advances are applications of the new fundamental theory of physical reality called single field theory, or SOFT, S-O-F-T, which he has developed. SOFT is based on the 5-dimensional Einstein-Kaluza space-time geometry. You all know what that is? He will explain that. Explanations of paranormal phenomena emerge naturally from this space-time structure. Professor Ziegler has just published a book which is on, I believe, right there. It is called To Die For, the Physical Reality of Conscious Survival. It gives a thorough explanation of this theory in layman's terms and explains what happens when we die. And that's always been the touchstone of the skeptics is, well, you claim you have these magnificent claims, but how do they work? Well, Dr. Ziegler has a theory. This is how all of this comes together. And that's what this workshop is this morning. It is titled A New Dimension of Consciousness, Realizing and Visualizing Higher Spaces. So, Dr. Ziegler, are you well rested and ready to go? Welcome. In a moment.
No, you leave that on there. I'll just transfer the latest one to this one, and I'll put the yeah, well, I can. So can you operate from all this technical stuff? You want to hook the video up to this one?
He thought he was speaking at 10 o'clock, so we would have some shuffling of our program. Decided to eat a full breakfast this morning instead of rushing over.
You all see me as though we want my normal state. My sex, one piece or something. Okay. Now, well, I'll talk while I'm setting up. So. Basically, this is a workshop, not talk, so I write things to play with. Yeah, go ahead. So I have some handouts and things to play with to sort of prove my point. This is a workshop, not talk. Unfortunately, I'll make this as experiential as possible. It's sort of hard to make something as abstract as a four-dimensional space experience. Unless, of course, you want instant enlightenment. And of course, as far as I'm concerned, mystical enlightenment is nothing but actually reaching out with your consciousness and touching the higher dimension space. But that's my theory. I'm doing theory later. Right now, I'm just doing a four-dimensional workshop. So this is geometry. So, let me see.
Plane or spherical?
Pardon?
Plane geometry or spherical?
Well, that's just it. The type of geometry is open to question. Let me see. Okay, that's the wrong one. Okay. Yes, stop for a moment. The problem is I rewrote this like several times. Last time was a couple days. It's only on my computer, not on the white. No, right here. Can I just disconnect this?
Sure, go ahead. You need some help, Jim, or are you?
No, I'm
good to go.
The thing is, we only normally do three-dimensional space.
Just shut the lid and just put yours on top of that.
We only normally do three-dimensional space. Technically, there are four-dimensional space. Now, we're bound to thinking of four-dimensional space-time as in general relativity.
There was stop here?
No, yeah, go ahead, start. So we were commonly thinking in 3 dimensions of space, not 4-dimensional space-time. Four-dimensional space-time, so I'm going in totally different. Now the problem is, since we normally think in 3-dimensional spaces, it's hard to conceptualize 4-dimensional space. But 4-dimensional spaces actually imply. Steve, why don't you go?
Yeah, I think we need to do your little key combination to get it shown through.
It's not showing up on my computer. Cut it off. Excuse me, it's going to take one. Just hook that one off.
We're just giving you an opportunity to develop the virtues of patience.
I don't know. Speak another language.
Yeah.
They call it inland. I want it down.
It's early in the morning. I don't work well before later in the morning. No, it's not. That's now it is.
Yeah, Mac.
I'm just used to bringing in my own computer and setting up. Everyone else does it that way.
You have a short version.
This is the short version. I'll just back away. I didn't know how many people were going here, so you can share these. There are 20 pairs of scissors here, so just sort of passing each other to go through. But I do have enough of these to pass around. Do not bend or fold these, please. That will come later. Do not write on them. And when the time comes, you'll pass it on Scotch tape. We're back in 2nd grade, except they just bring the ruler of computer thing. That's the second part will say that. Okay. Yeah. That's what I'll take. I did something like this in the American Physical Society. We just didn't, all the other computers were working. Mine wasn't working. You had to bring your own computer in there. So I read off my computer, which is unfortunate because I had specific equations. That's physics, so I had specific equations. A lot of people see it, couldn't see them, so they had to imagine them. Imagine physicists and scientists having to think and imagine. It was a disaster. Okay, this is geometry, but this is not kind of geometry where you're going to sit and draw things. This is dimensional geometry. Now, the concept of dimensions was a long time developing. You go all the way back to the Greeks who developed the first concept of geometry. Euclid. Euclid didn't write geometry as much as he collected all the geometry that was done before him and put it into a single book, and he had his own on to reflect geometry. So Euclid's books on geometry, which were still used up until 50 or 60 years ago in high schools around the world, said there are 3 dimensions. In the early 1800s, they discovered the possibility of non-Euclidean geometry, so there might be higher dimensions of space. Now the question then is, why don't we sense those higher dimensions? Albert Einstein worked on a 5-dimensional theory, 4 dimensions of space, 1 dimension of time, so the 5-dimensional space-time in the 1930s, and actually unified physics. And physics has been unified using 5-dimensional theory, but now they do superstring theories and things trying to use 10, 11 dimensions because they don't know it's already been done in 5 dimensions. And there are books on it and everything else that I found in my historical searches. And I'm trying to introduce those books to the rest of the physics community because they're trying to do something that's already been done. Almost there. Now, the problem, as I said, is that we can't use higher dimensional theories because we don't know what a higher dimension would be like. All we know is if you have a higher dimension of space, it would not be like the normal 3 dimensions of space. Because normal 3 dimensions of space allow planets to orbit suns and so on and so forth. There's a special law called the inverse square law. It works in gravity, electricity, magnetism, and everything. That as you get twice as far from something, the field, electrical, magnetic, or other field goes 1/4 weaker. Or grows weaker by 3/4, 1/4 its original strength. As you go twice as far, or 3 times as far from an object, the strength of the field, gravity or electricity, is 1/9. As you go 4 times further, it's 1/16. That's the inverse square. You square the distance and do the inverse. Now that depends on space being 3-dimensional. So the obvious argument is that if we have higher dimensions of space, we wouldn't have an inverse square law, and all the planets will orbit into the sun, and all the atoms would collapse. But that's assuming that a 4th dimension would have the same characteristics and properties as our normal 3-dimensional space. That's where science is wrong. The higher dimension does not have the same properties. So how do we study the higher dimension? Well, we study 2-dimensional surfaces in 3 dimensions. Euclidean geometry is just geometry of a flat surface. If I go to a sphere, the surface of the sphere curved in a 3rd dimension, then that's no longer Euclidean geometry. That is a Riemannian geometry. And that is the geometry of a sphere or an ellipse or an egg shape or a donut-shaped torus. That's the geometry they use in general relativity to explain gravity. Although the quantum theorists say that's wrong. Then the quantum theorists are wrong. But unfortunately, 95% of physics is quantum theory nowadays. So this is very important that we study these geometries. And we do it by comparison, which is what we're going to do here. We're going to compare to lower 2-dimensional surfaces here with 3 dimensions, and I'll explain the geometries this way. Now, why bother? I've already done why bother because it's important science. But why bother realizing this? Because according to my theoretical work, if it's true, and my theory may not be true, but I think large parts of it are, because other people are coming up with very similar theories. There's a lot of people coming together. It's not just me. Say that there are higher dimensions. Why don't we realize them? Well, I think we realize them. We can think of them. As I said before, if we experientially touch that higher dimensional space, that is what happens when a person has near-death experience. And people who have near-death experiences, according to Raymond Moody, they have actually experienced another geometry because they come back from their near-death experience and they say, geometry in there isn't what I was taught in school. Of course, they're taught Euclidean geometry. They actually experienced a higher dimensional space. And that's why they change. And I explain that in my theoretical work. But if we can realize, I believe mystical enlightenment, like Buddhist mystical enlightenment, or the Christian mystics, I think when they become enlightened, mystical enlightenment, they actually touch that higher thing. And I think our normal 5 senses, touch, smell, and everything, they work in 3-dimensional space. We have a 6th sense, and that is our sense, the sense we use through mind and consciousness directly in the higher dimension, make contact, glory, touch, and see, the sense in the higher dimension. That is our 6th sense. So all this fits very well. One time you hear about this higher dimension geometry fits very well with exactly what the mystics are saying. It's phenomenal. What they're saying in a lot of cases rings true if you understand this higher dimension of space. That's why we bother. If I can help you realize that, in a sense, I'm preparing you for what will probably happen after you die. Because of according to my theory, mind and consciousness survive death in this higher dimension. So that is the advantage of realizing this higher dimension. I'm not talking about a four-dimensional space-time continuum. I'm talking about the fourth dimension of space, so spatial, not temporal, timeline. So if I talk in terms of Einstein, it would be the fifth dimension of space-time. So sometimes I may say the fifth dimension of space-time, otherwise I say the fourth dimension of space. They're the same thing, depending on how I apply them to the physical world. Now, there would seem to be no simple reason why to adopt it. Think about it, except for this. This does not mean that it is impossible to think about it, only that any reason to adopt the fourth dimension must be supported by evidence. Very, very strong evidence. In science, adopting higher dimensions of space, they adopt them only to explain strange physical phenomena. And to tell the truth, this is not enough. They've known about these possible higher dimensions of space for about 150 years now, and they still have not completely adopted them. They're only getting used to it in the past 30 because it's such a large step. It's anti-positivistic. Empirical positivism was started by Ernst Mach in the 1870s and 1880s. He's founded empirical positivism. That is what influences all of our science and has since the 1890s. And Mach even states in his book, Science and Mechanics, that he would never believe in a higher dimension of space until he could actually see things pop into and out of our three-dimensional space. Well, they've been doing that for 70 years. It's called quantum mechanics. It's not manufactured quantum mechanics. But then, Mach didn't believe in quantum mechanics. Mach didn't even believe in atoms. He thought atoms were just speculative, and they'd never be verified. He didn't, even though Mach's ideas influenced Einstein, and Einstein's development of relativity theory, Mach never accepted Einstein's relativity theory either. I mean, he is super positivist. Basically, if you can't see it or sense it, it doesn't exist. So if you can't see it, and then a telescope would be extension, microscope would be extension. Those are the extensions of our five senses. So if we didn't sense it somehow, even through extensions, or by experiment, observation is sensing something, it's not real. And we shouldn't even bother with it. So we're beyond positivism now, which means we're beyond normal science right now. Because normal science is still very positivistic, although we don't like to admit it. Now, using higher dimensions to scientifically explain things must be the only way to explain things before we get out of the higher dimension. If there's an alternative theory, they'll take any alternative theory rather than do higher dimensions. I can do everything right now with the fourth dimension of space. I can do everything that quantum mechanics does, everything superstring theory does, everything brain theory does, the standard model of quantum mechanics. I can do it all. So simple I could teach it in high school physics class. Yet they're inventing all this new mathematics. They keep on inventing new things that are untested, unverifiable, and unproven because they don't want to adopt one single higher dimension. Now, the first question we'll have to ask is, what is space? Since I'm talking about three-dimensional space, what is space? The concept of space is necessary to consider the possibility of making measurements. We can't measure things unless we have a concept of space, because the concept of length doesn't make any sense. But I'm talking about an abstract concept of space. We have a normal, everyday concept of space. But I'm talking about how can we abstract the concept of space so we can put it into theories. The abstract idea of space. And believe it or not, this is a prerequisite for all science. They have to have a concept of space such that we need it to define concepts such as speed, acceleration, volume, area, etc. Volume, area, or geometric, that was easy. But defining speed and acceleration, the basis of all physics, which is the basis of all science. All science is developed from early physics. Aristotle had no concept of space. He had a concept of place. Things had a natural place. If I drop this, its natural place is the center of the earth, so it would keep its natural place. but he had no concept of space. He knew there were 3 dimensions, but he didn't have a concept of space. That's why, according to Aristotle's theory of motion, if I threw this, I go like this to throw it, as soon as I left my hand, it would fall straight down. So they couldn't explain space. The ancient Greeks, as smart as they were, that's one of the things they couldn't do. They had no concept of space. They couldn't explain speed and acceleration. It wasn't until about the year 1300 at Oxford University in England, when this was being started, they finally were able to accept the concept of space and accept the concept of space.
When did that happen?
About 1300 Oxford University. They're called the Oxfordians,
Got it.
the scientists there, or philosophers. And still from 1300 up to 1687, when Newton published the Principia, there was no theory of motion. So these things took a long time. We sort of had to brainwash ourselves over a long period of time to accept these concepts, these abstract concepts, to build our first science. So it took science more than 2 millennia to develop the first abstract concept of space, and find that this concept is not as easy or self-evident as it sounds. Now, why are there only 3 dimensions? We have no idea. There's no logical reason why there are only 3 dimensions of space. It is an experiential, an observation. We can't logically argue 3. It used to be that scientists 150 years ago, they say, well, if we had 3 dimensions, as I said, the inverse square law of gravity would fall apart and all planets would fall into the sun. But they're using the tail to wag the cat in this case. That's a product of 3-dimensional space. It's not the reason why there's a 3-dimensional space. So we can't have higher dimensions of space as long as they don't have the same properties as our space. And there's more or less verification of higher dimensions, or they're implied in physical theory. Electromagnetic waves would not exist without a higher dimension of space. The science doesn't accept that. It's in the mathematics, it's in the theory, but science doesn't accept that now. They just work with electromagnetic waves. These things work because of electromagnetic waves, but the mathematics implies there's a higher dimension of space. Electromagnetic waves are transverse waves, like that. But there's none effect waves, compression waves, like sound. According to the theory of electromagnetism, there is electromagnetic longitudinal waves, which would be like sound waves, so electromagnetic. They've never been detected. According to electromagnetic theory, electromagnetic waves can travel backwards in time as well as forwards in time. Of course, they forget backwards in time because that wouldn't make any sense. They're only worried about traveling forward in time. There are 4 big holes in electromagnetic theory that makes the little theory look like Swiss cheese. Yet it's never been questioned. I've been trying to point this out in scientific audiences. And they go, there are things in electromagnetic theory that electromagnetic theory says exist, but we've never been able to measure them. Or where they exist. They have position and they have a length. But we can't measure them in 3-dimensional space. So guess where that length is? In the higher dimension of space. That's why we can't measure that length. It's called a magnetic potential. It would be literally a magnetic volt. You have electrical volts. That's potential. But they're also magnetic volts. They're theoretical constructs. Experiments prove their existence, but we can't measure them the way we do electrical volts. We can't measure them because they exist in a higher dimension. It's that simple, but science won't accept that. Science, as I said, is very positivistic. But we normally only sense 3 dimensions. Other than that, there's nothing that says we should only be 3 dimensions. We judge space by the relative positions of material objects. That's relative space. I can tell there's space because of the distance between us. I can tell there's another dimension of space between the distance between Boyce and myself. I can tell there's a 3rd dimension because of the distance between the ceiling and myself. We judge the 3-dimensional space by the material objects. Now, what that says is material objects are 3-dimensional. That doesn't mean the space between them is 3-dimensional. The material objects are extended in 3 orthogonal directions. Orthogonal means at right angles. Height, width, and depth. But that's material objects. We imply the dimensionality of space because of the object's ability. But that does not mean space is 3-dimensional. It can have higher dimensions. It's just that material objects are stuck in 3 dimensions. Why or why not more dimensions? Beyond the fact that we normally sense only 3 dimensions of space because of material objects, there's no reason to believe that there are not more dimensions. There's no physical reason. There's a little rule of thumb in science. If science doesn't say it's impossible, then it could be possible. Of course, there's nothing in science that says that the paranormal is impossible. The science refuses to look at the possibility that it could be possible. There are a whole lot of things in science, a lot of rules in science that science breaks. And as a scientist, I hate to admit that. But as a historian of science, I say, well, yeah, that's how science progresses. But unfortunately, scientists are bad about that. There could literally be an infinite number of dimensions as long as our material universe is only specified by the 3 that we sense. Now, I'm not talking about our physical universe, because physical and material are 2 different things. Things can be physical and non-material. The electric field, the magnetic field, and the gravitational field are physical things. Real honest students, physical things. But they are not material. Matter is material. That's all. Our material universe could actually be, if we have an infinite dimensional space, then our 3-dimensional space could be 345th, 346th, and 347th dimension out of that infinite. Take any 3 numbers from 0 and infinity, and that those 3 represent our 3-dimensional space within an infinite space. And when they talk about multi-universes, other universes, well, we could be the 345th, 6th, and 7th 3-dimensional universe, and then the 1000, 1001st, 1002nd would be another 3-dimensional universe within that infinite number. This brings in the whole thing of multi-universes or multiverses, as they talk about, which lets the science fiction runners' imaginations run wild. This will not change unless we find that we need those higher dimensions so that we can uniquely explain some form of physical phenomena. And when I do my other lecture, I'll show how the higher dimension of space explains what's called dark matter, dark energy, and also allows for me to have a theory of light, mind, and consciousness, and the survival of consciousness. In other words, the adoption of a real fourth dimension must not just be sufficient to explain physical observations of phenomena, it must also be necessary. Necessity implies a completely unique explanation when no other alternative explanation is being found. Now, what is dimension? Dimension is anything that we want it to be. We could adopt temperature, density, and humidity as 3 dimensions, which technically you do these words with higher dimensional spaces. Which basically that's what they do in weather. If we want to talk about the dimensions in weather, you talk about these 3. However, it's customary in physics to think of spatial dimensions as length, width, and height. Some mathematicians and scientists even talk about fractional dimensions, also called fractals, but that was popular in the 80s and 90s. It's not popular now. The 4th dimension of time was added by Einstein in 1905 to make the space-time continuum, but he did not do this without physical justifications to do so. Even we know what time is, but making time the 4th dimension within what is called a manifold. So a 3-dimensional space and 1-dimensional time within a 4-dimensional manifold. He had physical reason to do this, very, very concrete physical reason to do this. And of course, that was special relativity and then later general relativity, which are both accepted in science now. But he couldn't do that. He had to take a lot of convincing. It took 10 years to convince the scientific community to accept special relativity. So, where the geometry of the higher dimensional spaces came from? Well, I'm talking basically about elliptical spaces and Riemannian geometries. That means an n-dimensional space would be embedded within, thanks to the Iraq War, everybody knows what embedded is. They stole it from the scientists. And the n-dimensional space is embedded in an n+1 dimensional manifold. Now, this is Riemannian geometry. Then all the different non-Euclidean and Euclidean geometries are special cases of the overall Riemannian geometry. So what Riemann said when he did his paper on this in 1854 was that an n-dimensional space is always going to be embedded in an n+1 dimensional manifold. So if we have a three-dimensional space, therefore, mathematically, we must also have a four-dimensional space in which it is embedded, a four-dimensional manifold in which it is embedded. Einstein thought that was space-time continuum. But then that means four-dimensional space-time continuum must be embedded, and then that becomes four-dimensional space-time continuum, that becomes the n-dimensional, and it must be embedded in n plus 1. So mathematics implies there's a higher dimension. But they've forgotten this. Now, when you have Riemannian spaces have positive curvature. That would be like a sphere or an ellipse or something like that. Then you have a saddle shape like this. That's a negative curvature. So the center would be down here, but it curves away from the center, so that would be negative. Flat is zero curvature. Those are three special cases within Riemann geometry. I'm talking about a closed space, so it would be a closed thing, which would be spheres and things like that. Now you can have single polar and double polar Riemann spaces, or single polar sphere and then a double polar sphere. If this is a globe, and I put a pen on the equator, and I move the pen all the way around the globe, it goes through a pole, to the other side, it's gone through one pole, so it's facing the other direction. Then as it comes back around to the other pole, it comes back to the original position, and it's pointing in the same direction. That's a double polar Riemann surface sphere. But there are Riemannian spheres, Riemannian surfaces, curved in higher dimensions, where there's only one pole, so that when you come back to the same position, you're pointed in the opposite direction. This is something you don't even realize. But a Mobius strip and a flying follower are both single polar Riemannian surface curved in a higher dimension. I'll show pictures in a minute. The sphere, ellipse, and torus is a donut shape, are all double polar. Our three-dimensional universe is double polar because we can draw two-polar Riemannian sphere in it, so it's double polar space. The higher dimension, I believe, is single polar, which allows me to explain the spin of an electron or a proton. Now, this is so well known that the first book on it, popular book, came out in 1884, a novella, Flatland, The Romance of Many Dimensions. And that has become, in the meantime, one of the most popular books ever printed. It's still out in about 4 or 5 different editions right now, even though it's written in 1884. And it's written by A-Square. It's about two-dimensional beings on a flat surface experiencing third dimension. And the characteristics. And it actually tells you what the characteristics, those same characteristics and properties of higher dimensional space. It's a way of reaching them. And it was written by Edwin Abbott, but originally signed by A-Square. A-Square was the main character. It's A-Square on a piece of paper. We're going to some properties. Now this is a Mobius strip and a flying bottle. Mobius strip is just a strip of paper. It's twisted around once. And if you go all the way around that, it's both sides of the paper are one continuous surface. The Klein bottle is a higher dimensional, instead of one-dimensional thing curved in two, as a Mobius strip, with a two-dimensional surface. The Klein bottle, there is no inside or outside of that. It has no inside and outside. That is one continuous surface. You can touch anything inside. You can touch any point on that surface from the outside. That's all outside surface or all inside surface, whichever one. And that was by Felix Klein. He developed that in the 1880s and he started talking about these different geometries. But those are both single polar spaces.
Wait a minute, how do you touch the inside from the outside?
You'd have to have a long finger to go through it. But technically there is no inside or outside. It's harder to see. If I actually had one, if I had $150, I could actually buy a model of a physical model.
That would be good.
Yeah, I wish I had one for you. I should have got one on a physics t-shirt. I ripped it off if you can. It would really been ripped off because they canned me on Friday and they tore off the physics lab on Monday. And I think they threw away half the year. They were going to throw it away until their chemistry lab manager came and saved it. Did it itself and stored it in another room. They didn't care about it. I wish I had done that. I would have got all the physics equipment. Okay. Charles Howard Hinton worked in the 1880s. He was a mathematician, master's degree geometer, and ended up in the United States teaching. Ran from England because he married 2 women. That wasn't very well liked. Or there's some question about this having divorced the first woman before marrying second. So he first went to Japan and came to America. Ended up at Princeton and different places. But he developed the first system of realization of the four-dimensional space. He also wrote, well, here, this is from Wikipedia. He wrote science fiction short stories. I don't know if they're science fiction. They are more stories to illustrate the higher dimension. They weren't technically science fiction, but Wikipedia calls it that. Which, if you want to look up, just go look up Charles Howard Hinton. They'll have more on mine. I'm not technically taking this from Wikipedia because I've written lengthy things on Charles Howard Hinton, had it published. I got they published their stuff from my articles on. They give me credit. Sometimes they do Wikipedia, they give you credit. Other times they just steal my stuff without giving you credit. He is interested in higher dimensions, particularly in the fourth dimension, and is known for coining the word tesseract. A tesseract is a four-dimensional cube. Four-dimensional cube. And for his methods of visualizing geometry of the higher dimensions. And he was doing this in the middle 1880s. Now he was working on, he was actually trying to philosophize the work of William Kington Clifford, who died in 1879. He's one who developed the original concept. Edwin Abbott's book, Flatland, was just an exposition of Clifford's ideas. Clifford's the one who started in England. In fact, he's the one that introduced Fremont's work to England and then tried to develop the physical theory of electromagnetism out of it. He worked with Maxwell, who developed electromagnetic theory. They were friends. But he tried to visualize. He thought that we should be able to visualize this higher dimension space. Now, in 1880, he wrote an article called What is the Fourth Dimension? And the publisher got a hold of this, and he said, well, he changed the title to Where Are Ghosts? Or something like that. So Clifford's work, or rather Hinton's work, although it was strictly trying to explain geometrical stories to explain geometrical concepts, became associated with the genre spiritualism. And I think that sort of discredited him. And scientists could ignore him easily. And part of the problem with the higher dimension movement in the 1800s was it became a good place for ghosts and spirits. So I'll talk about that a little bit later. So the scientists then ignored the mathematics. And at one point, Hinton even suggested time might be the fourth dimension. That was not original with him. That was from Clifford and Sylvester that he picked up and got credit for it because he wrote about this. Clifford and Sylvester didn't write about it. Hinton did, so he got credit for it. But this was sort of in anticipation of Einstein's space-time, 1905. A lot of his short stories were published together in a book, Scientific Romances. Very interesting book. It's a collection of short stories. And this was by Swan and Sonnenschein, published this in 1884, between 1884 and 1886. It's sort of a serialized collection. That's why it's over 2 years. And Abbott's Flatland was related to this. I don't know exactly what the relation was between Abbott and Hinton, but they were sort of swapping ideas and not giving each other credit for it. Neither of them gave Clifford any credit, and all started with him. Now, this is Hinton's system for realizing higher dimension. We have a point. Pointer. We have a point. A point is zero-dimensional. That is not a physical point. That is a mathematical. It has 0 dimensions. Then we have a line. It's one-dimensional. This line is supposed to be the same length. We take the point and stretch it in one dimension. That gives us line. We take the line and stretch it in the second dimension. That gives us this square. Then we take the square and stretch it in the third dimension. That gives us a cube. So those are all supposed to be the same. These lines are the same length as these lines. It's hard to do that on the computer. The exact same, but we can understand. So we have 0 dimension, 1 dimension, 2 dimension, 3 dimension. The 0 dimension is 1 point. 1 dimension has 2 points and 1 line. The 2-dimensional object here has 1, 2, 3, 4 points, 4 lines, and 1 square or 1 surface. Then the 3-dimensional object has 5 points. Oh, that's wrong. It doesn't have 5. It has 8. Sorry about that. That's 8. Mistyped that somewhere. It's got 8 points, 12 lines, 6 squares, and 1 cube. So this is a progression. 1 point, 2 points, 4 points, 8 points. 1 line, 2 lines, 12 lines. Those are progressions. So from that, we can sort of project what a 4-dimensional square will look like. and that is the tesseract. This is the tesseract. It's 6, if you count that, 16 points, I hope I got those numbers right, 32 lines, 22 squares, and 6 cubes. Here's 1 cube, 2 cubes, 3 cubes, 4 cubes, 5 cubes, so the outer cube makes 6 cubes. Now the only problem is, if we could see that in 4-dimensional space, all those 4 cubes would look like cubes, and they'd all be the same size. So we're giving depth. This smaller cube is actually further into the 4th dimension of space. So our mind is giving it depth that would make it the same size. As you see something going away from you, it's smaller, smaller, smaller. This inside square is as big as the outer square, but it's further in the 4th dimension, so it just looks smaller. That's the depth of the 4th dimension. If you can imagine that, you're thinking in 4-dimensional spaces. That's what we want to try to do. We want to be enlightened individuals. And a possibility, this is the geometry experience after we die. To understand the tesseract, the mathematician will first make an analogy with the Necker cube. What is a Necker cube? A Necker cube is a plain cube. It was a cube for 2,000 years before Necker came along. But Necker is the one who noticed, he's a crystallographer, and he's the one who noticed that it's an optical illusion. Which is out? Which is closer to you? This square here, or that one in the back? Your mind will transpose it like this. That's what Necker noticed. That's why it's called Necker cube, because of the optical illusion. That is a 3-dimensional cube drawn on a 2-dimensional surface. But your mind gives it the depth perception. Your mind adds the 3rd dimension. That's the illusion. So, is it out? Is it front out? Or is it back out? Your mind superimposes the extra dimension over the 2-dimensional drawing. Is that side out? Or is that side out? Is it front side out? Or is it back side out? Is it front side out? Or is it back side out? You can sit there and play mind games and, whoa, physics, so in and out. But that's not the illusion. See, again, that's a 2-dimensional rendering of a 3-dimensional object. Your mind gives it depth. Now, this is any artists in here? If you do the history of art, artists didn't discover depth perception until around the year 1300 or something. That's when they started doing paintings with depth perception. That's crap. My nephew, he started painting, and he all on his own. He developed depth perception in art in his paintings when he was 13 years old. He has supposedly part of the history of the artists that used depth perception until around the 1300s or something like that. We knew depth perception a long time ago. Now, what's in or out, which face of the cube is in or out, forward and background, is controlled by your mind's eye, because your mind sees all the lines and squares of equal size, except for the added depth of the figure. That's because your mind thinks in 3 dimensions and adds a 3rd dimension to the 2-dimensional drawing. Now, what we have to do is we have to extrapolate that idea to the tesseract. We have to trick our mind into thinking that all those cubes that make this up are the same size, and that little middle cube is actually the same size as the outer cube. Now, this is a problem because I'm drawing a 4-dimensional, this is a 2-dimensional rendering of drawing like a 4-dimensional object. That's what makes it hard. But if we can imagine all these lines make this up, all these lines the same length, all these cubes are not distorted, and they're all the same size. We're thinking in 4-dimensional space. We have just become an enlightened being.
You spelled that.
What?
Last line. Number 2.
Where?
Spelled that.
Oh, sorry. Like I say, I made radical changes to this just a few days ago. Now, if you watch the object, as I said, if you watch an object disappear into the distance, it gets smaller. So basically, the tesseract, that smaller square in the center, is just disappearing into the 4th dimension. If I were to go to the 4th dimension, what would you see? Around my center, you just see me shrinking into my center, having the depth of the dimension. They've done that in Star Trek, haven't they? The original Star Trek, back in the 60s, actually did that. where they are reading a being, an advanced being, computer-generated being from a advanced civilization that they destroyed. First, it is sideways like this, it folds into a line, and then the line goes like that. It was just shrinking into the fourth dimension of space. This stuff is used all the time in science fiction. It would make science fiction interesting.
Is it a cube within a cube like, or is it more than
No,
a cube?
they're more than one cube. Well, that's the exercise we're going to try to do in a few minutes. Okay, now hold this tesseract around in your mind's eye so the outer cube becomes inner cube and vice versa. Oh wow, you can't do that, can you? It's harder when you're working four big and four dimensions. Now hold it around in your mind's eye so that the left cube here moves to the outside of the cube and all the other cubes rotate around it to basically what I'm telling you to do is actually take it like this and just rotate it in a higher dimension. Not that easy, is it? Enlightenment is not that easy. Well, this would explain that people that have near-death experiences. That's why they can't explain what they saw in our work. Because our works are made for three-dimensional objects made to experience higher dimension. Same thing with enlightened people. That's why they say everything in paradox. Oh, it's inside, but it's not inside. It's outside, but it's not outside. This also explains the way particle duality in modern physics disappears if you take a higher dimension for the same reason. Just rotate this around your mind's eye in that higher dimension. If you can do this, you will be thinking in four-dimensional space, and you will attain to a new level of consciousness. The problem is that you can only imagine two-dimensional drawing, and the next you would get three dimensions with your imagination, but you can't do this with this drawing. Why can't you do it with the drawing? The way we do it now is we use computer-generated programs. This is what I was talking about. See, this is your cubes, your 8 cubes. They fold in, and then this is the outer cube coming out. I want you to do that in your mind. It's a good exercise. Now, instead of doing it the way by comparing different cubes and number of points, the size and everything, the way Hinton did it, and Hinton, after 20 years of trying, finally admitted this to be, he couldn't imagine that higher dimension. And he didn't just do cubes, he did spheres, he did three-dimensional octagonal figures, he did all kinds of figures trying to imagine higher dimension. He couldn't do it. But now, we've got to make it easier with computer animation. There's a much nicer computer animation that I'm going to copy and put it here. But we have this one. This is the other one I was talking about. This is folding it in and out. And if you want to find these, this is the address for this one. I just copied it and downloaded it. But this is to show you, see the cube, that inside cube that goes to the outside and becomes the same size. And there's a lot of this about imagining this on the internet now. There are a lot of programs like this that you can watch on the internet, or like these, you can copy them and download them and use them for your own benefit. This is not to make you sort of seasick. Or you can go to YouTube. YouTube has a lot of animations. There are 3 pages, a list of 3 pages of animations. These are just 2 of the animations they had. This is the address. Don't copy it down. Just go to YouTube and do a search on Tesseract.
Put it on Facebook.
Pardon? Put it on Facebook. This? Yeah, I can put this on the ASPSI page. But really, just go to www.youtube.com and do a search on Tesseract. Because they're also changing all the time. The one I wanted to show you was taken off. I was actually going to use my computer with my AT&T hookup and go to YouTube now. And they have a really good one. It's actually made from one of the computer games. And a guy runs up and he sees a two-dimensional figure folded into a cube. Then he runs a little bit further around the corner with his gun, and he sees the first one I showed you. It's really good. But they took it off about a month ago. They took it off about a month ago, so I can't get it easier to show you. So we'll skip that part. However, the very best animation is one that you can imagine with your own mind, which is what we're trying to do. These others are mere crutches to help start the process. Give you something to think about. with one computer that really counts, and it's the best computer ever invented, and that's the one that's between your ears. All other computers are mere poor copies of that. So use that one. Don't use these. Use crutches for starting. Then use this one. Not my computer, of course. Now, what happens is we're folding and unfolding. So take your scissors and cut out that cross that I have on the paper. This is the experiential part of this. I'll give you a few times. Sorry, like I say, what we're going to do, don't fold it, just cut it out at this point. I don't want you to fold it because I have a few things to tell you how to fold it. It's the how to fold it that is what we're looking for. Yeah. I passed, I got 40 of them. Okay, we just got to that. There might be something to that. It's hard enough finding a place that had, I want to find a place that had like 10 pairs of scissors in one package, or 2 in a package, just like find another big ones. No, dollar store had these same things for $1. I was rather cheap. I got 2 for $1 at big ones. Actually, that wasn't big lots, that was all of them. They had 2 for $1. This is manual dexterity. Now let me explain how to use the scissors.
That's all right. I'll just watch. I wasn't for 30 seconds or second.
Okay. Here, this is coincidental. Okay, pretty much everybody done? Well, you can cut one off. Now, I don't want you to fold these. I don't want you to fold these yet. The figure up here is the cube unfolds into this. Now, before you start folding, I want you to try and fold that. That is a two-dimensional surface. Try and fold that without going into a third dimension. You can't. It's impossible. What I'm trying to point out is folding and unfolding. The act of folding and unfolding requires a higher dimension of space. Not the figure, it's the action that requires higher dimension. Not the figure, the action requires. To fold this, you have to fold it or bend it into the higher dimension of space. Now that's the important point. That's the important point. Now go ahead and fold it along the lines and fold it into a cube. Here's some Scotch tape. And when you're done folding it, I want you to tape them together and make a cube on top. Here's one case. Because we're going to need some cubes in a minute. I bet you can guess what the next part is. Now, while you're doing that, I'll say this the whole way. I got enough scissors. Tape now last for about 10 years. I stopped somewhere and one of the, no, it was when I came here yesterday. One of the scissors fell on the car and somebody said, well, you can actually just go a lot of times. It does tell us stuff there. So we got some cubes made. As soon as we get some cubes made, we're going to go to the next part of the exercise. And that next part of the exercise is going to be making a tesseract from the cubes. Now, if you take the cubes apart, is like the animation I had. You take your cubes apart and you stack them in a cross. There's 5 long, 2 up here, and the one sticking out like this. That is an unfolded tesseract. This is just the animation you saw a little while ago. The first one, this one just folds in, this one folds in, this one folds in, this one folds in there, this one folds in, this one folds in, and the one that's back there is the one that was in the center. Then this one is the one that wraps around all the others, just like that animation. Now, one of you brave souls take 8 of these cubes, stack them like that, and try to fold that. Remember, the folding, you have to go in the higher dimension to fold that. Try folding those into the tesseract. And you should get something that looks like this, my 3-dimensional model of the tesseract. This is my first attempt, but someday I'm going to learn well and weld some copper tubing together and make a nice one. I'm showing you a 2-dimensional rendering of the tesseract. This is a 3-dimensional rendering. Now, it's hard to go from 2 to 4 dimensions with the drawing. It should then be easier to go from 3 to 4 with an actual figure like this. It's not any easier. But if you do this, and other people try, I said there is actually a lot about this on the internet. So if you're interested in this, go on the internet, look it up. 20 years ago, I think I was going to talking about this. In the past 5-6 years, there's a lot of people talking about this. It was very popular in the late 1800s because of the book Flatland and Andy's work and Hilbert's work. And in like Science magazine and some of the popular scientific magazines, there's scientists actually arguing in the pages of the general population magazines whether or not it was even possible to realize or think in 4-dimensional space. So this is very, very popular in the 1880s, 1890s. Doing just this. Imagine they used a lot of scissors, a lot of paper. Imagine everyone. You are now right. It's not easy. That's why if you could do it, it would be great. Now, you've probably seen this particular cross figure. Does anybody recognize that? A popular painting?
Oh, yes. Salvador Dali.
Salvador Dali actually used this cross and crucified Christ on it. Crucified Jesus on it. It's a very famous Dali painting. So, these mathematical ideas have actually permeated into the art community in many places. There are even some books, popular books written back in the 60s and 70s on higher dimensional space, 4th-dimensional space, and how it affects art. I can't remember the title of the book. It was just one written in the 60s and 70s on that. So this, as I said, is very popular. In other words, I'm not making this stuff up. It's just Tertium Organum. No, Tertium Organum. I'll talk about that. That's Miss Spence's book. That's like 1910, 1912. That's Florida's book. But I'll talk about higher dimensional. Has anybody been able to take a little cubes and please tell me? I'd be happy if one of you who becomes a light for this.
Okay, so we need to put 8 of them together.
But they just said, I don't know if you want to come up to the table. This is experiential. This is a word count. Voice was going to beat me up if I didn't do something. I plan on doing this before. We have volunteers here. If you think this is bad, think of I can't even do a model of a 4-dimensional sphere. You should see a model of a 4-dimensional sphere. That's really good.
Is there another one back behind?
No. There are 2 ways to draw this cross. You can have 5 across here and only this one, or you can just have 4 here and then this one is in the back. They're equivalent. I draw it this way because this is the way Dali do it. They're drawing this famous painting. So this is better for illustration.
Jim, you got about 25 minutes.
That's okay. How are we doing? Anybody? Here, step back so everyone can see that. What it looks like. Here, everybody see what that looks like now? This is what it looks like. Well, no, this last one goes up here. Does any of you think you can hold that in? Remember, you actually have to, you just don't fold it, you actually have to move into the higher dimension to do it. That's the hard part. Again, the fact that you have to move into the higher dimension to do it means you can't even start to fold it, because you can't move this material object into higher dimension. Because it's material. But that does not mean you can't think it. You can't materially do it, because the material world is three-dimensional. But your thoughts are not three-dimensional, so it is possible. That's why many people think it is possible to actually think in the higher dimensional space. So you can make it happen in your imagination. Well, it depends on how you define spirit. The scientists only define spirit. Spirit is not a scientific term. No force. Thought does not take force. Thought is potential, not force. He's really going crazy on this one. See what I mean? To fold it, just to begin folding it, you have to go to higher dimension. You can't do it. But in your imagination, there's no reason, no loving reason why you can't do it in your imagination. I have other models that I try. I work with time as a fourth dimension. That's difficult enough. But I try to think of time. It's also a good exercise to do this. In a sense, folded in time rather than in space. And this is what I've been trying to do since I was in college, like about 30 or 40 years. Picture a tree with its leaves blowing in the wind. Just the breeze, so the leaves are just going like this. A full green tree. When it's a silver maple, one side of the leaf is silver or gray, the other side is dark green. Now picture that, all the leaves in the tree rustling. You can hear rustling in the wind. Think of that. Now when you think of that, you think of it over time. Because these are waving back and forth. Now say, put a 10-second clip of that in your mind. And try and compress that 10-second clip down to 5 seconds, 4 seconds, 3 seconds. And try and picture that motion outside of time. In other words, try to take that motion of time and put it totally in two-dimensional space. What mystic would describe as seeing all time in the moment. That's a good exercise. I've been working on that one every once in a while, not instead of but I've worked on it every once in a while. That's a good motion because it's varied with all the different leaves rustling. Because silver green, so it gives you something to think about. Think about that and try in your mind. As a meditation exercise, try and think of that and press a few seconds of that down into a moment. You could experience timelessness in a single moment, which, as I said, that's what the mystic is talking about. Very interesting exercise. When I really, really work at it, I can get it down to shorter times. I just can't get it down to that time. As an experiment, when I was talking about these things down at the Division of Perceptual Studies down in Charlottesville, they asked me if I could apply this to experimental war. I said yes. I was suggesting getting someone who is enlightened, say a Buddhist monk who is considered enlightened, to see what he thinks about geometry, see if he recognizes his geometry, see if he can collapse the maple leaves into a single moment. And just find a way to test that. That would be a way of possibly verifying the site dimensionality. Probability rate. I have not mentioned quantum mechanics. I think quantum mechanics, although mathematically it's sound, philosophically it's low as crap. And I'm willing to take on the whole scientific community on that one. Because I know something better. Quantum theory works fine. I'm total Einsteinian. Einstein was right. There's nothing wrong with mathematics experiments in quantum mechanics. It's the interpretation. I can explain what the probability is. Unfortunately, when you're a physicist, the probability is the reality, not the material world. Right. The probability is the reality. We call it probability density problem. Electrons don't exist. Probability density problems are what really exist. That's a load. The electron is a real thing. And because they can't understand that, they substitute words for it. It's the finger pointing at the moon. Quantum physicists think the finger is reality, I'm sorry, I think the moon is reality. But quantum theory is just mapping, so what are you talking about is what I get to now. It takes
Einstein never agreed with it.
What's that?
Einstein never agreed with it.
I know, but Einstein for the last 30 years of his life was considered an eccentric by the people who liked him, and now by the idiot by the rest of the people. He did everything before 1925. After that, he hasn't contributed anything either. But his ideas now are actually becoming popular. That's because he was right. You're wrong. The ability to visualize. Now, you can use these as meditations. The ability to visualize the next dimension would be an enlightening experience, if not the next step in the ongoing evolution of human consciousness. I think that human species enlightenment is the next step in our evolution. The last step was consciousness. Various levels of consciousness, up to human level of consciousness, which is what we have right now. And that's recognition of self. Our next step is realization of this higher dimension. At that point, the whole human race will become enlightened. And that's the topic of my science fiction book that I sent to the publisher. EVO, EVO, short for evolution. Actually, I'm hoping if I can get a movie contract to give it to everybody. So I'm hoping to get a movie contract. I can put Matrix and Harry Potter and all that other business. Just trying to do this, even if you're unsuccessful, just trying to do this is mind expanding. So this is a good mental exercise for everyone to try. Now, I said, I predict this is the next step in human evolution. I'm not the first person to say that. Several years ago, this society took Buck's, 2001, Richard Maurice Buck's book. We took that as our topic for our meeting. Very famous book. But consciousness is studying the evolution of the human mind. We developed a theory that consciousness evolved through 3 levels. Simple and animal consciousness. And cosmic consciousness. Self-consciousness and cosmic consciousness. Word self-consciousness, as I said, that's part of my theory too. And then what he called cosmic consciousness is basically like Buddhistic enlightenment. I think that's where the whole human race is. Maurice Buck said that in 1901. The last, cosmic consciousness, was an emerging mental faculty of the human species, although some individuals had already taken that state. And I don't know what your religion is, but I would estimate that if they were nothing else, these people were at least enlightened beings. Jesus, Muhammad, Zoroaster, or Zarathustra, Buddha. And I believe that these people actually have near-death experiences. If you read, Buddha was enlightened by sitting for several days under a roti tree, and he saw, the devil and evil spirit and everything. I think he died. I think he actually had near-death experience. And Jesus was out in the desert, and Muhammad sat in the cave or went out in the desert, and these sounded like near-death experiences. So I think they actually experienced this higher dimensional reality. But then they interpreted it in the culture that they were Jews.
I just wanted to mention Paul.
Yeah, there are a lot of them, but these are the individuals. But what I'm talking about is not just individual. I'm talking about the whole human race, with advances in knowledge and everything, and training and education and everything. I think eventually the whole human race is going to reach this level. I think it's going to happen in the next 40 or 50 years. I certainly hope so. If not, we'll destroy ourselves. Now, then you have P.T. Uspensky, a philosopher. He expanded on Buck's ideas in Tertium Organum, the book, and several other books. The subtitle, at least one authority says the original subtitle when translated English was The Fourth Dimension as the Esoteric Nature of Reality. The editions now have a different subtitle, but I think this is from the original edition. And he talked about the fourth dimension of space back in 1912. As I said, in the 1880s, 1890s, this is a very popular subject. But after quantum theory, it just disappeared out of the scientific mathematical literature. It came up into a mathematical exercise after that. And I think that science is lost because of that. Now, the subtitle tells it all. The reading is far more interesting. Humans need to understand the fourth dimension to a higher consciousness. Uspensky's highest form of consciousness, equated to Buck's cosmic consciousness, was the fourth form. And if you read his list of different forms, the fourth form included, as a property, the sense of four-dimensional space, as well as a spatial sensation of time. The spatial sensation of time would be Einstein's space-time continuum. But also with a higher dimensional space, which he was talking about, five-dimensional space-time. Same thing I'm talking about in my theory. Another author wrote even another book that went further than this, and this was Robert T. Brown in 1990. He wrote a book titled The Mystery of Space, a study of the hyperspace movement in light of the evolution of new psychic faculties, and it inquired into the genesis and essential nature of space. Now, he gives a history of the development of hyperspaces and non-Euclidean geometries in the first half of the book, so it's a good scholarly book. If you don't know anything about the history of the work of Gauss and Riemann and others in developing the ideas of Lobachevsky and so on, he gives the history of it. Second half of the book, he explains how this is the next step in human evolution. Now, there's one problem with this. All the scientists and all the people who have talked about this stuff earlier than him always talk about the higher fourth dimensional space being a Riemannian positive curvature. 1919, Robert Brown says, no, he doesn't think it's a negative curve, Lobachevsky space. And if you know anything about history of science, this is 3 or 4 years after Einstein came out with general relativity and used the Riemannian space. So Brown was wrong in that point. But if you just ignore that little thing where he says that he doesn't believe higher dimension is Riemannian positive curve, then he has to be like this. Written in 1990. So the ideas I'm not expressing are not mine. They're the ideas of a lot of other people. Then there are survival theories that are based on these higher dimensional spaces. Mine would be Zollner, J.K.F. Zollner. J.K.F. Zollner was a rather strange character. I think he was in Bonn, German, working at the University of Prague in the late 1800s, and he's considered the father of modern astrophysics because of the work he did. He's also considered anything, still, 100 years later, he's considered eccentric, a crackpot, and an outright lunatic, depending on which dictionary source you go to. Why? Because he said when we die, our spirits continue to exist in the fourth dimension of space. Now, he did not develop a theory to say how that worked. He just posited it as a fact, an experimental fact. Then he used the mediums and some of the tricks of the mediums as his experimental verification that spirits existed in the higher dimension. Now, they do things like they take 2 blackboards. The scientists would take 2 blackboards and put a piece of chalk in there, blank blackboard. Put a piece of chalk in there, put them facing blackboard to blackboard, then tie them up with gigantic, humongous knots that could not be untied, and hand that to a magician or a medium when you come in. The primary medium for Zollner was Henry Slade, American. And they come and sit around the table or talk or whatever they do, and they hear a funny noise, and then they cut the knots off because the knots could not be untied. They literally cut them off and look at the board, blackboard, that had writing on it. And one example in his book, Transcendental Physics, which was translated in English in 1881 by Massey, he has a picture of the blackboard, and it's got writing, like 3 or 4 different lines. Now, Slade did not prepare this. The scientists prepared this before he got there. And the knot could not be untied. But the scenario fits for dimensions, properties, geometrical properties of a four-dimensional space. Because if I tie a knot, no matter how complicated I tie a knot in three-dimensional space, if I look at it through the fourth dimension, it'll be totally untied. It's called knot theory, of all things. K-N-O-T, knot theory. It's mathematical. Three-dimensional knots are untied in the higher space. We see them as untied. So he said the spirits wouldn't have trouble untying knots because they weren't tied to the spirits. Also, if you have a piece of paper left there, put your finger on a piece of paper, like I've got my finger on the table. The tabletop is a two-dimensional surface. Let's suppose I was a two-dimensional being and I wanted to escape. The tabletop is for your piece of paper is your two-dimensional prison. Try and escape from that prison. The edges of walls you can't go to. Try and escape from that prison with two dimensions. You can't go to the edge and you can't go any further. How do you escape? You go in the higher dimension and go around the wall. If I was in a three-dimensional cell with no doors out, if I could put my material body in the fourth dimension, I could walk right through the wall. That's the properties of fourth dimension. So he said the spheres were actually going through the board. They weren't confined three-dimensionally, so they could go inside the fourth dimension.
Could that explain why UFOs take a human being through a solid wall?
Yes, that does explain. That is what the UFO people say. And a lot of people think UFOs are actually coming from alternate dimensional realities rather than distant space because of these properties of four-dimensional space. So you see, this four-dimensional space explains all these things. So it works. Now, this is the book he wrote, Die Transcendental Physics. It was published in 1878, translated in English in a shorter version, 1881 by C.C. Massey. I've already scanned this book, and I put it through an optical character reader and copied it exactly. And I actually published it on the internet until AOL took down my webpage. It was on my journal of physics on the internet, but it's gone. If anybody really wants this, send me an email and I'll email you a copy of it. I think it's a small enough file that I can actually transfer. And I've actually taken Zoltan's pictures and actually put them in the PDF file. So if you want a copy of this, send me an email and I can email you a copy of the book. Now, Zollner chronicled all his experimental tests, but unfortunately, Henry Slade was shot by the mission, the SPR at Sheepgate. And so Henry Slade was detained, and it ruined Zollner's career and careers of a few other scientists. That's why, although Zollner is considered the father of modern astrophysics, he's also considered everything from eccentric to outright nuts. One source, actually, I read dictionary type, encyclopedia source. I'm talking about Britannica, these type, not Wikipedia. I'm talking about Britannica traditional encyclopedia sources. It says he just got a little crazy during his later life. Because he went on then, after he was really criticized by Ernst Mach and others, they went on to say basically, he went on to say that Jesus was in the fourth dimension space and other things. You get a little bit weird as a fighting with people who are criticizing him, almost like things are happening today. There's like, this is. Unfortunately, his career was ruined after that. My theory, I'm not going to tell you about my theory, that's a later one. But one thing I have to do is I have to be very careful, because I go to the American Physical Society with my theory of dark matter and dark energy, and don't talk about this stuff. But really, they're both applications of the same theory. So it's a single theory that has multiple applications. So I have to be careful. I can't mention this stuff when I go to the American Physical Society. I can't even say the word, I can't see that there's physics of consciousness, which is legitimate with some consciousness, with some scientists, because they're the sort of walk of the apple. So I have to be careful of all of the result. I don't care. I'm going to take them on. Another place this higher dimensional space is used prolifically throughout science fiction. You don't see science fiction without some type of implication or reference to a higher dimensional space. Now, many sci-fi stories often portray advanced EPIs, extraterrestrial intelligences, with higher consciousness, thinking, and higher dimensions. For example, the famous movie Contact with Jodie Foster. They get the message from outer space, first contact with beings, and they get thousands, tens of thousands of pages of data, but the pages don't match each other until somebody figures out the pages are two-dimensional. If you put the pages together like this, the aliens are thinking on three-dimensional pages of data. In other words, they think in a higher dimension. This is used, it's almost, most sci-fi books have alien intelligences thinking in higher dimensions. Just what I'm trying to get us to realize. Star Trek uses hyperspace. They go through hyperspace to travel beyond the speed of light. In other words, they leave our three-dimensional space and go into what they call a subspace. But subspace, technically, is just the fourth dimension, by another name. In the movie The Fog, which came out about a year and a half ago, these people are in a small town, and all of a sudden, a fog rolls in. Really weird creatures insects this big come out and start gobbling up people and tearing them apart and everything. There's a four-legged thing about as tall as the Empire State Building. Then at the end of the movie, very end of the movie, you found out, well, some scientists were doing some experimental work and tore open a rift in our space and let in these creatures from another dimension. See this all the time. Now that also perpetrates an error. The dimension, this fourth dimension, is not another place. It is an extension of our three-dimensional space. There may be other 3, 4, 5-dimensional spaces, but the fourth dimension I'm talking about is not another place. It is actually an extension of our three-dimensional space. Just as the height here, third dimension, is an extension of this two-dimensional space. My new book, Evo, if I may be so bold as to advertise the book, hopefully it'll come out in about 3 months. It's about this next step in evolution. So I explain all the science in the book. It's a geek science fiction, which means I do all the science in the book and explain what's happening. I'm just using sci-fi as a method. I'm turning the tables. I'm using sci-fi as a method to teach physics. Now other movies use this as well. You just watch the old Doctor Who series. He has the TARDIS, his time machine. It's a 1950s police box, about 2 meters wide, 2 yards. It's older, 2 yards wide and 2 yards deep, about 2.5 yards high. And he goes inside this little box. That's another world there. It's like it's bigger than a city block inside. He's got thousands of rooms inside this. Well, it's only a small box. That's a properly 4-dimensional space. If I take this cube, and this cube intersects this tabletop 2-dimensional space. In 2 dimensions, it's only a point. But if in 2 dimensions I go to that point, then I can go into the whole box, which is much bigger than the point. That's the TARDIS. It's the same thing in Harry Potter. When Harry Potter, gate, whatever, is 2 or 3 quarters, walks into the wall, you catch the Hogwarts Express, where does he go? He goes from 3-dimensional space into a 4-dimension. In other words, a parallel 3-dimensional that's connected by the 4th dimension. Everybody uses it without knowing it. Even in the very first Harry Potter movie, when he goes to Diagon, all the bricks fold back in the wall, and he goes into Diagon Alley. Where's Diagon Alley? It doesn't even show up in normal streets. That's because it's in a higher dimension, 4th dimension. Everybody uses this without even knowing it. It's like we intuitively know what it is, but it's just putting it conceptually and abstractly into a scientific form. H.G. Wells' time machine. One of those famous books, he used this 4-dimensional space-time 10 years before Einstein did it. But he also did a lot of short stories. One Wagner story where a teacher at a boys' school finds this gooey green mass, takes it to his boys' school, hits it with a hammer to test it to see what it is, and it explodes in a green cloud. And he disappears. His students can't see him. He disappears for 2 weeks from the point of view of the normal 3-dimensional world. But he's still there. He sees everybody as a fog. And he goes, and he can't touch anybody. They're not listening to him because he's gone out of 3-dimensional material space just a little ways into the 4th dimension. So no one can see him from 3-dimensional space, although he can see them. And he sees floating heads. Mostly of dead people, but a few of the floating heads are actually people he knows in life. What are the floating heads? A metaphor for human consciousness and mind. They're floating heads in this higher dimension. There's a wall, and after a while there, he goes to a wall. And he goes to the wall. The closer he gets to this wall, the less he can see the real 3-dimensional world. It's fading to it. When he gets to the wall, he says, I don't think I'm supposed to go over that wall. I better not go over that wall. So he goes back. Because he knows he will die if he goes over that wall. What is that? What is he explaining? What is that metaphor? The near-death experience walking into light. The wall is like a near-death experience. It's all metaphorical. But he's saying near-death experience is happening. He published this in 1995.
Dorothy and the Wizard of Oz.
Yeah, it's all. People are using it intuitively without saying what it is. But all these sci-fi stories, their properties are of the 4-dimensional space, just the way we would interact with 4-dimensional space. Then, of course, modern physics, you have superstring theory, brain theory, supergravity theory, fluid theories, fluid flying theories, all this. And my theory. We're all using it. It's actually very popular. I'm going to show you. There's absolutely no physical reason, rule, or law of nature that requires or guarantees that we would be unable to perceive higher dimensional space. So trying to realize the higher dimensional space is a legitimate mental exercise. As I said before, there's ample evidence that it physically exists. It just wouldn't be the same as the three-dimensional space. That's why we don't. Our normal 5 dimensions, we are, in a sense, brainwashed by our normal 5 senses to think materially. We think physically, because that space is, that higher dimension is physical but not material, then we would become like and others that we do. Though there's not circumstantial evidence to strongly imply the reality of a higher dimension to our commonly perceived physics space, no matter what particular physical theory you choose to believe in. So this was done independent of my theory. Thank you.
I know that Jim got started 10 minutes before his time to start was scheduled. So most of that time was taken up by introducing him. So let's give 5 minutes for questions before we have a recess for 5.
Oh, you want to do it with the microphone or just...
No.
Don't need
yes,
it.
use the microphone for your questions, please. And give your name.
Coy Walker. Jim, aside from the authorities you cite like Krensky and Brown, what would be the justification for regarding imagining, or however you would phrase it, imagining or picturing the fourth dimension as more than a mental exercise and is actually a level of consciousness, a higher level of consciousness?
There, Amber said, I think when she writes Harry Potter and all these other sci-fi stories, I think they're actually intuitively sensing, not their reasonable 5 senses. I think they're intuitively sensing higher dimension. So I would consider this sort of almost as evidence of a higher dimension, that we can't perceive it. Thinking in it, perceiving it and thinking in it higher dimension are 2 different things. And I think experientially, according to the characteristics the mystics describe after enlightening experience, what they're explaining is the mathematical properties of higher dimensional space.